Okay, so let's solve for plane 1, 1, 0. So we'll pick our point of origin. Once again, this is our x, y, and our z. X, y, and z. So this is our point of origin since everything is positive. So 0, 0, 0. So the first thing we want to do is we want to look for the reciprocal, which is 1, 1, 0 reciprocal, which is 1 over 1, 1 over 1, 1 over 0, which will give us 1, 1, infinity for our plane. And so from our point of origin, we go 1 on x. From our point of origin again, we go 1 on y, right? So it is infinity towards z, towards the z direction. So we trace it upwards here, then transmit it there. We transfer it also upwards in z direction, right? So I just want to take my time to erase this so I don't confuse us. Erase the line, the trace line. So we are going to join this also, and join this also. So I want to change my ink to shade. No, this is yellow. So shading with yellow, we have this. Now this is slicing through our middle atom. That's the pregnant atom in the center. So this time around, we don't just have corner atoms, we have center atoms. And then the first thing I want us to know about this diagram is the fact that this diagram, right, is a rectangle. It is not a square. It goes through diagonal. So rectangle is longer than a square, which is the same thing, the same length that is breadth for the area of a rectangle. But we cannot just assume that it is A. If this is A, if this is A, then the down part can never be A. If this is also A, this line can never ever be A. So we have to look for it. We transfer it out here, right? So this is our A, this is our A, but this is unknown. This is our unknown. Now let's solve for our unknown so we can march forward. Let's use green to solve for our unknown. We apply Pythagoras theorem, which is let's call our unknown x square is equal to a square plus a square, right? Let's say this is equals to unknown is equals to x. So x square is equals to this, so we have it to be equal to 2a square. X square is equal to 2a square, so x is equal to root of 2a square, which is equal to root 2 times a. This is a dot. A gave up his own square. Sorry, let me write that well. A gave up his own square, right? So we know the length of this place to be equal to root 2 dot a. So let's go ahead now and solve for our area, or let's look for, this is the area of the plane, right? We just found the area of the plane. We just move forward to find the area of the plane. Now let's look for the number of atoms centered on the plane. Right here we have 90 degrees on our 360 circle, right? So it's going to also be 90. Sorry, let me change my ink to white. So for the number of atom, right, we have 90 over 360. Once again, cancels. We know where this is leading to, 1 over 4 times 4, because we have it in 4 places. 1 here, 1 here, another 1 here, and another 1 here. So we have it in 4 places, right? Then plus the 1 centered atom, right, which is going to be equal to 2 atoms. Then for the area of our what's it called, area is going to be equal to root 2a times a, right? Because it is this height, our a here, times this long distance that we found, this long distance, right, which is our 2 root 2a. I think I should be able to write it up here. We have it to be root 2 dot a. Cool, but I need my pen so I can always change. So now let's apply planar density PD for planar density for 111 is equal to number of atoms centered on the plane. We have 2 atoms, right, over the area of plane, which is 2 root 2 times a, so we have root 2 a square, right? So if you go ahead and punch 2 over root 2 in your calculator, it's going to give you root 2 divided by our a square. So let's substitute the value of our a square from this place. So we go ahead and say P planar density for 110 is equal to root 2 over 4r over root 3 all squared, right, which is equal to root 2 times root 3 squared, right, over 16r squared. So which gives us root 2 times root 3 square is equal to 3 root 2, 3 root 2 over 16r square. That's the answer for our planar density of plane 110.